Welcome to Science Encyclopedia College. This is physics class. We have questions on dimensional analysis. Question has to do with dimension. The question here says the force F acting on the wings of an aircraft moving through the air of velocity v and density rho is given by the equation F equals to kVx rho y az, where k is a dimensionless constant and a is the surface area of the wings of the aircraft. Use dimensional analysis to determine the values of x, y, and z. Now, this question is similar to the first question I solved on dimensional analysis. You get back to my video to watch that, a very important question I solved, usually for YX standard. Now, we have this question here, and then the first thing you have to do in this question when you see is to bring out the equation given to the relationship in the question. So let's have given. We have F is equals to kVx rho y and az. So this is y. So after I've done that is to write the dimensions of each of the quantities present in the relationship. This is v. So we have the dimension of F. Of course, from the question we know that F is for moving through the air of velocity v and rho density. So we have air here is force, the force F, okay, so is force, the dimension of force is L mt minus 2. I've done a video on this, LT minus 2. Now the next one is K, of course K is dimensionless, so it is taken to be 1. The next one is velocity V. So dimension of velocity is the same thing as LT minus 1. That's displacement over time. So force here is really given to us here. So we have the next thing here is dimension of rho. The rho here stands for density. So dimension of density is mass over volume. So mass is m, the volume here is L cube. And then the last thing, of course, is the dimension of A. And A is equals to area. Of course, I said it's area. So it is area, let's see, is it area? A. Okay, A is the surface area. So area is L squared. That's the dimension of area here. Now, after you are able to do this, the next thing we are supposed to do is to replace these dimensions back to the relationship that was given. So instead of writing F, we're going to be having L mt t minus 2 equals to, no need of writing the k, so we have velocity, we have Lt minus 1. Don't forget, if there's any letter you attach to this, so the letter here is x, that's the power. Then we have rho, instead of writing rho, we're writing ml minus 3 y, then of course the next one is a. Of course, A is L squared, so that is Z, 2Z. It's 2Z because 2 is X that is here, X, so 2 times X. Oh, let us do it gradually. So we can just have L is equals to here, squared, open bracket, Z. So if we go ahead to carry out our operation, this is mt minus 2 equals to, this multiplies this to be Lx t minus x times 1, and then m multiplies this my, we have L minus 3y, then we have L2z. This is what we have. Now, after I've done this, the next thing is to equate the exponents you have based on each parameter or each quantity present. So, but before we do that, we will carry out a relationship. Let's see that we have L equals to mt minus 2. Let's bring this together. We have L here, Lx, so we still have L here. It's going to be multiplying L minus 3y, multiplying L2z, then that's for L. Then, so the next one is t minus x. Let me clean this. So the next one we have is m raised to the power of y. Okay, so that is it. Now the next one we start our comparison. So if you come here, we have L. What are the exponents of L, the power of L? L here is 1, which will be equal to L here. But before we do that, let's carry out this so that it will be clear to us. We can have this equals to L. In indices, when we have the same terms multiplying each other, you pick one and add the power. So we have X, this is going to be plus minus 3, that's minus 3y, plus 2z. So we now have the next one is t minus x my. So what I do is, since they are all L times L, we pick one L, we add this power. We added the powers, and then so don't forget this is t. So after doing that, we now equate the exponents. So L now, what is the power of L here is 1, which is equals to the power of L here. We have x minus 3y plus 2z. This is what we have. You can call this on equation 1. Okay. Let's continue here. The next one we have is here. This side we have m. Do we have m here? Yes. We have m, which is equals to the power of m here is just 1. Since it's just 1, equals to 1m, so just 1. And then the power of m here is just y. The next one, Lm, okay, we have t. The next one is t. The power of t here is minus 2, which is equals to the power of t here is minus x. So we can therefore say that from here, this is equation 2, this is equation 3. So we can therefore say that y is equals to 1, x equals to, this comes to this, x is going to be 2. So the next one we're supposed to get is to get z. So putting, okay, I think yes, z we're supposed to get. So putting x, putting 2 for x and 1 for y in equation 1 gives, so we come back to here, we have 1 equals to, instead of x, we're writing 2 plus, okay, so it's minus 3, open bracket, 1, look at it here, x, see, instead of x we have 2 minus 3 times, instead of y, we write 1, then plus, instead of writing 2, writing 0, that we have, okay, that's the 0 we're looking for, so it's just 2z. So to be 1 equals to 2, this is minus 3 plus 2z. So we have 1 equals to 2 minus this minus 1 plus 2z. If we collect like terms, this comes here to be 1 plus 1 equals to 1 plus 1 equals to 2z. So 1 plus 1 is 2, which is equals to 2z. If you divide both sides by 2, we have 1 equals to z. So you can have z equals to 1. So this is what we have. So therefore, they said use the dimensional analysis to determine the velocities of x, y, and the values of x, y, and z. So what we do is we come back to the main question. We already know that x is equals to 2, y is equals to 1, z equals to 1. So we come back to the original equation. We have the equation given to us here as f equals to k. So to become v, the value of x is 2, since it's raised to power of x. We have rho, value of y is 1. And then we have a, that is surface area, the value of z here is 1. So we can just leave them like this. So this is the answer to this question. So this is the solution. It's not difficult to solve. So thank you for watching, and don't forget to always like, to share, and to subscribe to my channel for more videos.